Here we have this formula that says A of t equals A sub 0 e to the negative kt, where A sub 0 is the initial amount, k is the decay constant, t is the time, and A of t is the amount after time t. So let's use this information to do this following problem that says the half-life of radium is 1690 years, very long time. If 50 grams are present now, then how much will be present in 550 years? Please round to the nearest 3 decimal places. All right, well, first we have to find K, which is the decay constant. To do that, we'll apply this formula first. So this formula is A of t is equal to A sub 0 e to the negative kt. Yeah, I'm giving myself some space right now to write. All right, now we're dealing with the half-life, and the half-life is the amount that's present. Actually, no, half-life is the time it takes for the original substance to become one half of that substance. So again, half-life is the time it takes for the original substance to decrease to one half of that original substance. Okay, so that's the situation when we have one half A0. Okay, that is, we're going to replace A of t with one half A sub 0 because we're looking at the time when the original substance was one half of the original substance. So that's one half A sub 0. A sub 0 is the initial amount or the initial amount of the substance. All right. And then we'll say A sub 0 is equal, I'm sorry, one half A sub 0 equals A sub 0 e to the negative k. Now, we're talking about when the substance is half of the original substance, and in this case, is given to be 1690 years. All right, so t is 1690 in this situation. Okay, so we have the equation 1 half A sub 0 equals A sub 0 e to the negative k times 1690. Now, let's solve for k. To do that, we can actually divide both sides by A sub 0, and that will cancel out all the A sub 0s. Isn't that cool? So then we're left with 1 half is equal to e to the negative, and let's go ahead and write the 1690 in the front because usually we write the coefficient in the very beginning or the front and then the variable k. So 1 half equals e to the negative 1690k. Now to get the k by itself, we're going to take the ln of both sides. So it'll be ln of 1 half equals ln of e to the negative 1690k. All right, we'll go ahead and calculate ln of 1 half later on. So let's go ahead and just bring it down for now. The ln and e will essentially cancel each other out, and so we're left with negative 1690k. Now to get the k by itself, let's divide both sides by negative 1690. All right, so k is going to be an ln of 1 half over negative 1690. Let's use a calculator to figure that out. All right, so we want ln of 1 half. Now 1 half is the same as 0.5, so we'll go ahead and just say ln of 0.5 divided by negative 1690. And that's going to give us this number in scientific notation. It's going to copy all this in. K is equal to. Now let's go ahead and rewrite the scientific notation in regular notation. So this says times 10 to the negative 4. So that means since the exponent is negative 4, we're going to move the decimal point 4 places to the left. And if you do that, we're going to have 3 zeros additional. So there'll be 0.000 4101 46261. So 0.0004101 is our decay constant. Now let's go ahead and try to solve this problem. Okay, so it says here that 50 grams are present now. Then how much will be present in 550 years? So to do this, so to find that out, I'm going to go back to that original equation, A of t. So once you find k, we can always go back to the original equation. A of t is equal to a sub 0 e to the negative kt. All right, okay, we want to know how much will be present in 550 years. So how much will be present is the A of t. And we're talking about a time of 550 years. So in this case, t is 550. So let's go ahead and plug that in. So it'll be A of 550 is equal to A sub 0, that's my initial amount. So here I'm given an initial amount of 50 grams. So we'll put that in for A sub 0. That's E to the negative K. And now we know that K is 0.0004101 46261. And then times T, we now know that's 550. Okay, so we're now going to calculate A of 550. And we just have to simplify 50e to the negative 0.0004101 46261 times 550. And let's use Desmos calculator for that. 50e to the negative and 0.0004101 46261, and then times the 550. All right, I believe everything's in order. All right. And we went around to the nearest 3 decimal places, so we can get Desmos to do that for us as well. So we'll type the word round, and then go all the way to the end of the expression, and put a comma, and we'll put 3 for 3 decimal places. And we're given 39.903. So that's our answer. Okay, so the half-life is 1,690 years, and 550 years is a small amount of time compared to the 1,690, and so that means there's still some substance left after the initial 50 grams, all right? So, so I believe that's also in grams, so, okay, grams, yes, okay. Okay, so there was 50 grams left, and now what's left is 39.903 grams. All right, and that's how to do a half-life problem.